I'm in lab 1 in Good Memories also because I think it's funny to sit with a thing that says, where's the bacteria thing? Bacteria. Dad. It's gotten a little weird. So, graphs of polynomials. We actually did this not long ago in advanced. So, graphing graphs of polynomials. So, for example, if I wanted to graph the function p of x, p just means polynomial, equals x cubed take 4x. I'd factorise it first, so x out the front, x squared take 4, and then I realise x squared take 4, that's the difference of two squares, so I've got x take 2, x plus 2. And I wanted to sketch it. Well, first of all, we'd have to think to ourselves, what are our zeros? Well, first of all, we've got this one, and that's x equals 0. So that was that one. We've got this one. So x take 2 equals 0, x equals positive 2. So that's that one. And you don't have to write that step out, by the way. And we've got this one, x plus 2 equals 0, so x equals minus 2. So there are our three zeros. So this is y. This is x. 0, negative 2, and positive 2. And then we've got to think to ourselves, well, it's got to go through all those points. Is it going to go doom, doom, doom? Or is it going to go doom, doom, doom? And you have to do the doom, doom noises when you do it, otherwise you fail. So then we have to look at the behaviour of the polynomial at large x. So what we're looking for is what the polynomial is going to do when we're like in this region, or you could have looked at it when we're in this region. Technically, the way to write this is as x tends to negative infinity. So negative infinity is this one down here, yeah? Because that's getting like bigger and bigger and bigger, but negative. And px tends to what? So positive or negative? Now, this is, like, it's confusing. We've done this before. Please don't let this notation freak you out. And you could also look as x tends to positive infinity, p of x tends to what? Positive or negative. So, and positive infinity is just this region up here, you know. So for this one, behaviour as x tends to, well, let's look at negative infinity. So let's just say x equals, well, you know, we're looking for anything pretty much less than negative 2, yeah? So if x equals negative 5, so I've just gone with negative 5 because I know that's less than negative 2. That's less than my last 0 on the left. P of x was p of negative 5. We're chucking negative 5 in. Comes out as negative 5 times negative 5 take 2 times negative 5 plus 2. We could have put it into x cubed take 4x, same diff. So that's going to come out as negative 5 times negative 7 times negative 3, which is, I mean, I don't even care what the number is going to be, but it's a negative times a negative times a negative, which is negative. Which means we know that we're down here. So when we do sketch it, it's going to look like that. We don't care about where these turning points are. So when I say turning points, we don't care where these are. Where you learn how to do that in calculus. We have not done calculus yet, and that's in the advanced course. So that's how you do a graph of polynomials. I'm going to talk about multiplicity next.